In this video, we'll be looking at different sensor platforms for UAVs. What can we actually put on these UAVs and capture from the sky? Well, our first basic sensor is our RGB sensor, which captures visual pictures looking in the red, green, blue color spectrum. This is basically a representation of how our human eye sees light and allows us to capture photos that look like a standard photo that we take with our mobile phone or normal camera. Not all cameras are created equal. Some cameras will have higher resolution than other cameras, and the higher we fly, the higher the resolution of the camera will want, because we'll want to be able to still see those fine details. So drones started off with fairly low resolution cameras of a few megapixels, and now cameras in the range of 20 odd megapixels are becoming quite common. These cameras can also take video, so you can do video or still photographs. Another sensor we can use that's commonly used within the agricultural settings is NIR cameras, or near infrared cameras. Now, near infrared light is invisible to the human eye. It's something that we can't perceive, but we can use it for agricultural sort of applications to do vegetation analysis, looking at different types of vegetation, trying to classify different types of vegetation, and looking at vegetation health, for example. The vegetation will look different in this different spectrum. Now, talking about different spectrums, we can use multispectral cameras. Multispectral cameras basically use spectrums of light that, once again, we can't see, just like our near-infrared ones, but we might have different spectrums of light that are well targeted to a particular application. And there might be things that we can see in a different spectrum of light that we just can't see visually. Once again, these can be used in agriculture, but they can be used in a variety of different areas around condition assessment. These cameras are quite expensive, and so that's one of the things that holds back these cameras being widely used. But we might be able to do, for example, if we've taken some pictures in an agricultural setting, use a transform on this data to work out what our plant health is and what parts are going well and what parts are not going well. We can also use thermal sensors, and we've talked previously about thermal imaging for imaging things like power lines, for example, looking at faults and trying to identify faults. We can also use them for tracking people as they run around within a scene. Another area we can use them is in fighting forest fires and looking for the hot spots or identifying new sources of ignition that are being spread in a forest fire. LiDAR is another technology that we can use. We've talked about LiDAR previously, looking at depth being generated using lasers, and we can use these for creating point cloud sort of mapping. Here we won't have some of those beautiful textures that we're talking about where we overlay those textures over these point clouds, but we will have a really accurate representation of the distance of all those different point cloud positions away from things. And one thing we often use within our drones is a gimbal. And our gimbal helps us stabilize our camera and move that camera around so we can look at that camera and move that camera to different positions and look at different poses. But it also allows us to track objects. So our drone might be flying around and that gimbal might be locked on a particular person or an object or something like that. But it also allows us to move it around and look at different positions. Our gimbals also actively, but also passively, with a bit of decoupling, try and remove some of that noise from our images and make our images or our video that we're recording smoother and less noise from vibration being induced into those images.